For the sixth assignment for Business 232, supporting your project, you have the choice to either do an analysis of variance and ANOVA test or a regression analysis. In this case, I will demonstrate both. For an analysis of variance, we are considering if there is a difference in the population parameter given samples from 3 or more. So the statement is, given 3 samples from a population, can we determine if it is the same population? In other words, if the population means are equal. We will do this test assuming a significance level of 0.05. To do a single factor ANOVA test, we need sample data from those 3 samples. In this case, we show that we've calculated the mean and the variance. But to do an analysis of variance test, the most straightforward way is to use the Excel function for a single factor ANOVA. So we go to the Data tab in Excel, and we have previously loaded our data analysis pack. We go to Data Analysis, and the first choice is an ANOVA single factor. You choose that, we end up with the argument box. The first thing we need to do is to put in the input range for our data. So in this case, I will put in the range with the column headings plus the 5 data points for all 3 samples. I will note that yes, labels are in the first row. I'm using the standard significance level, alpha is 0.05. And I would like to put the output on this same sheet, and I'll put it in, let's say I will put the data in the position just here below. I hit OK, and Excel will generate the single factor ANOVA results. So what we see here is that in the ANOVA, we have the between and within sum of squares, the degrees of freedom, the mean sum of squares, the F-test value is the mean sum of squares between divided by the mean sum of squares within. We calculate a p-value, and there are 2 ways now to test the validity of this ANOVA test. First is we can compare the p-value to the significance level alpha. We see that 0.01 is much less than 0.05. In this case, we would reject the null hypothesis that the 3 population means are equal. The other way to test this is the Excel function gives us the critical F value. If we compare the F-test of 6.75 to 3.88, again, we will conclude that we will reject the null hypothesis that the 3 population means are equal. The second option for assignment number 6 is to do a regression analysis on your data. And again, we will use the Excel function to do this, but first let's look at the data. In this case, we ask ourselves the question, is there a relationship between the price, we'll call that the independent variable, and the number of frets, the dependent variable. Now this may appear to be a made-up problem, but we'll use this in any case. So we have 2 columns of data. Data for the price and the number of frets for all 20 of our guitars. Doing the manual method to calculate the slope and the y-intercept, we need to first calculate the mean of x and the mean of y. We then calculate each x value minus its mean. We need to square those values and take the sum of those squares. We calculate each y value minus its mean, and we take the product of x minus its mean times y minus its mean, and we will sum those squares. The slope then is the calculation of the sum of squares of x minus its mean times y minus its mean divided by the sum of the squares of x minus its mean, and that gives us a slope of minus 4.4 times 10 to the minus 5, nearly 0, minus 0.00004. The y-intercept then is calculated using the formula for the mean of x minus the slope times the mean of y. For that, we get a y-intercept of 20.788. This would allow us then to calculate any value of y, the number of frets, for a given input value of x. But let's do the same thing using the Excel regression function. So again, using the Data tab, we go to Data Analysis, and in Data Analysis, Excel gives us a function for regression. So for the regression, we need to input the y range, and I will give that the number of frets. So that is the column heading plus the data. For the x values, again, the x values, column heading plus the values. I note that I do have labels of the column headings. We will do a standard regression analysis at a confidence level of 95%. And in this case, we want to put the output range in this same spreadsheet, same worksheet, starting here. And I would like to see a line fit plot of the data. So we hit OK. And what Excel will now give us, if I come down further, is Excel gives us the input data for calculating the regression. It actually does an ANOVA test, but the two values that we need are the y-intercept of 20.788 and the slope of minus 4.4 times 10 to the minus 5. These are the same values that we calculated above. Excel also gives us a line fit plot. Let me bring that up here and let me expand it a bit. So we see that the raw data is scattered across, and the best fit line is nearly a horizontal line. That best fit line is calculated from our slope and our intercept. And you will note that because this line is nearly horizontal, a slope of nearly 0, that there is no relationship between x and y.